Okay, I'm going to be solving the USACO 2019 February Contest Bronze Problem 2, the Great Revegetation. So, a lengthy drought has left Farmer John's N pastures devoid of grass. However, with the rainy season arriving soon, the time has come to revegetate. So, in Farmer John's shed, he has 4 buckets, each with a different type of grass seed. He wishes to sow each pasture with one of these types of seeds, and being a dairy farmer, Farmer John wants to make sure each of his cows has a varied diet. And each of his cows has 2 favorite pastures, and um, he wants to make sure that different types of grass are planted in each, so every cow can choose between 2 types. And Farmer John also knows that no pasture is a favorite of more than 3 cows. So please help Farmer John choose a grass type for each pasture so that the nutrition needs of all cows are satisfied. So in the input, there's going to be an integer n and an integer m from 2 to 100 and 1 to 150, where n is the number of pastures and m is the number of cow preferences or lines of input. And then after that, those are just like, let's say cow A likes pastures 4 and 1, cow B likes pastures 4 and 2, and so on. So the output has to be the grass types for each pastures. So output an n-digit number with each digit in the range 1 through 4, which represents the grass seed. And the first digit corresponds to grass type for field 1, and so on. And if there are multiple valid solutions, we have to print the smallest n-digit number that is among them, which means that we're going to have to make this the smallest, and then this the second smallest as possible, and so on. So when we look at this problem, we first think about this, like, we know that the grasses for pastures 4 and 1 have to be different, and 4 and 2 have to be different, 4 and 3 have to be different, and so on. So then we notice that we're trying to find the minimum possible grass type value for each field. This means that we're going to try to see what grass types are already in the fields that these numbers are corresponded to, and you're trying to find the lowest available grass seed that doesn't match. So let's say here grass type field 4 has a grass type of 3, then field 1 also can't have a grass type of 3. And here, if field 4 has a grass type of 3, then field 2 also can't have a grass type of 3. So what we're doing here is we're trying to find what answers we can't have instead of what answers we can, and find the lowest possible value that we can have by finding what grass types we can't. So let me display this in a spreadsheet. So let's just create some kind of array that's gonna say what grass type it contains at the moment. So since they're going to be n, which is five pastures, we're going to say pastures, which is 1, 2, 3, 4, and 5. Now in pasture 1, all of them aren't going to have a grass type yet, so we can set it to 0, let's say, because there is no grass type of 0. It's only 1 through 4. And let's see, for pasture 1 can't have the same one as 4 or 2 or 5. But we see that right now that none of the grass types are actually determined for any of these fields, which means that we can just set this to the lowest available grass type, which is going to be 1, from 1 through 4. And then for pasture 2, we see that pasture 2 can't have the same grass type as field 4, or field 5, or field 1. Now 4 and 5 are already determined. However, 1 is determined to have a grass type of 1 already. So that means that pasture 2 has to have the next available grass type. And that's what Farmer John wants to put on there. And the next available grass type after 1 is 2. And this ensures that 1 and 2 don't have the same grass type. Where here, 1 cow prefers to eat in pastures 1 and 2. And now we go on to pasture 3. 3 is connected to 4, 3, so it can't have the same as 4, but 4 has the grass type of 4 hasn't been decided yet, so this can still be 1 since it's the lowest possible value. 4 is linked to 1, 2, and 3, so it can't be 1 and it can't be 2. So this one has to be 3. And 5. 5 can't be the same as 2 or 1. 2 or 1 are each 2 and 1 respectively. So 5 can be the next available number from 1 through 4, which is 3. And this should match up with our sample output here. So what are we going to need? We're going to need, first of all, to store all these variables, and m and all of this, probably in some kind of two-dimensional array, which is going to be pretty convenient. And then we're going to have to look at each of these pastures one by one and see what they're linked to using the two-dimensional array. So we can see that like pasture 1 is linked to 4, 2, and 5, and pasture 2 is linked to 4 and 5 and 1, and so on. So we're going to need a for loop to sort through that. And then we're going to need to count, we're going to add the pastures they're related to, like that they can't have the same grass type as. We're going to have to add those grass types that those pastures already have to some kind of string, and then we're going to check what's the lowest available grass type available. And then we should just add that to some answer string, and then we should just be able to print that out. So we should be able to get started here. Here's the class. First we import our classes, alphabet util. So we need a static int n, m. We're going to need a two-dimensional array. And we're also going to need an answer as a string, so static string answer. We're going to need a buffered reader since there are plenty of input values, and a print writer. Output our answer. Then we're going to need a string tokenizer to be used with the buffered reader, so static string tokenizer st. And let's create just those for now. So we create our main. Just make sure there's an exception because we're going to be reading it from files. So n equals to buffered reader and file reader. So first we need to initialize it. So we create another function called init. And then we use string tokenizer to get the input values of n and m since they're on the same line. So let's keep it. And then we have to initialize our two-dimensional array, which is going to store the data. So it's going to be, since m is going to be the amount of input, we're going to need a to be a new int m and 2. And each of these two values are going to be the two pastures, like that can't be next to each other. So for int 0 and plus organizer line here. Okay, and then for our convenience, we're probably going to want to sort this. Right. Actually, we probably won't need to, since it doesn't really matter. So the thing is, we want to make sure that we want to know which pastures are are connected to each other, right? So we're going to want some kind of Boolean array to organize that information instead of just an integer array. So we should probably change this. So it's n by n, which is going to be the number of pastures. And let's say this is a Boolean array instead. And this is going to be, let's say, int a. It's going to be int b. Let's say this is b1, I guess, and b1. And then we're going to have to use these values to put each of the grass types in the two-dimensional array. So let's say that we put a value at 1, 1 inside of the Boolean array. That means that pasture 1 cannot have the same grass type as pasture 1, which doesn't make sense in the context of the problem. But if a value in the index of, let's say, 1, 2 in the Boolean array was true, then that means that pasture 1 can't have the same grass type as pasture 2. So that's what we're trying to do here to simplify the array. So let's say that A1, actually let's call this index 1 and index 2. Okay, so A of index 1, but since it goes from 1 to 100, we're going to have to do minus 1 to make sure the index fits. A of index 1 minus 1, 2 minus 1 equals true, and it should be the same for the other one too. Index 2, index 1. Because you don't want either of them to have the same grass type as each other. Okay. And then let's try solving it right now. So we're going to be creating another function after this. So in the solve, like I said, you're going to need a for loop to check each of the pastures, right? So there's going to be a for int I equals 0, since that is the number of pastures. So let's say we're going to need to use another Boolean array to keep track of the current pastures that can't have the same pasture as the current pasture. So like you're trying to find out which pastures you can't have with the current pasture. So we have to create another Boolean array in order to like organize the data and see more clearly which pastures can't have the same grass type as your current pasture. So that's just going to be one like section of A, which is the two-dimensional Boolean array. So let's call it no. Boolean no equals. And then now we're going to have to see which of them contain these values. So like what grass type each of these pastures have if it is decided. So for int j equals 0, then no dot length, because you're going through the new Boolean array, and j plus plus, taking the different pastures. So if no of j, so if they are connected, if they can't have the same grass type of each other, I mean no, then we should probably have some kind of string, right, to keep track of already taken grass type. So string, let's say available equals this, not available. Not available plus available plus equals. Oh wait, so we're also going to need to like have an array to keep track of the results, right? So each what grass type each of the pastures have. So we're going to have another Boolean array. So let's say here and result, or you could call it types, I guess. And it has to be in Boolean array. Types equals new Boolean n, because that's the amount of pastures. And then you have to do arrays.fill types with 0, because it's not decided yet which grass types are going to have, not res. Oh, it's going to be an integer. Types of j, because you're going to be adding what type of grass type they have. If we need to, we can do like if no j and types of j not equal 0, but it really doesn't matter, because when we check it, we're not going to be checking if like 0 is not an unavailable grass type, because it's not a grass type at all. So now we create an integer called, let's say, available, and we're trying to find the least grass type that works for us. So we can use a for loop, but we can also use like a while loop as well. So like while true. So if let's say not available dot contains available, let's see. Yeah, you have to do change to a string. So if that grass type isn't already taken, then if you do res of I, yeah, equals available, since that's going to be the answer. And you're going to have to break it because you don't want the while loop to keep on going. And if it's not available, then you're just going to have to keep on incrementing available until you get one. And after all this is finished, you should try to get your ant, like, get all the values in types and put it in one string. So we've already set ants, so ants equals an empty string for int I equals 0, I less than n, I plus, ant plus postgres I. So you're putting all of the types inside of ants, and then you're just going to dot ants. Of course, at the end, you always have to do in.close, out.close. Now we should be able to test this. First, let's test it with the sample input function. So, reader new input. I'll do this here. Okay. I'll be using this. Is this correct? Oh, there should be a 3, so let's try printing out. No. Let's try printing out A. False, true. So 0, 1, 2 connected. 1, 4. 1, 2, 3, 4. Yeah, 1, 4 connected. Yeah. Let's see, true. So 2 and 1 are connected. 2, 4. 2, 5. 3, 4. Yeah. 4, 1, 4, 2, 4, 3. 5, 1. Looks like it did go incorrect. Okay. Then we have to check the bottom. Let's try printing not available. So system. It should be correct. 1 isn't available. 1 for 4. 1 and 2 and 1 aren't available. Yeah, these 3 aren't available. One, 2, 3, 4, 5. 5, 2 is not available. Wait, 5 should be also connected to 1, right? 5, 1 is false. Oh, this should be less than m. Yes. M is going to be the amount of input. Okay, now it should work. Yeah, 1, 2, 1, 3, 3. There. So We can keep the system.out.println, but just change this to out.println, just in case we get any of the test cases wrong. Okay, set all of these. And let's try submitting it. Let's refresh. Java. Revegetation. Submit. Nice, worked. Okay, I hope you found this video helpful, and thanks.